Welcome back, students. Today we're going to be doing trigonometry problems. I hope you printed out the trigonometry worksheet, and I'm going to start with the first problem. Okay, if you haven't printed it out, I suggest you do that first. Pause the video and then come back. Okay, now the first problem says a 30-foot ladder leans against a building. The ladder makes an angle of 60 degrees with the ground. How far up the side of the building does the ladder reach? And then this part I'll explain in a minute. Let's go to the diagram. I started to draw it, but I did a more elaborate drawing than you have to do. You don't have to draw all this. I just did this to make it clear. It said a 30-foot ladder, so I tried to draw a picture of a ladder, put 30 feet. It said the ladder makes an angle with the ground of 60 degrees. So the angle is right here on the ground, between the ground and the ladder. The question is asking how far up the side of the building, how far up does the ladder reach? Okay, now it doesn't say the ladder is on the roof or anything like that, so don't put it all the way at the top. A lot of students do that, and that wouldn't be logical. Just put it somewhere around here. It's somewhere inside in the middle of the ladder, approximately. So I just leaned it here, and notice, since we want to find how high up the ladder is touching, which is what they're asking for, I call that X. Okay, it would really be this too, but you could put it right here, same thing. Okay, now to do that, you're going to use trigonometry. Let me first show you that you don't have to do all this drawing. You could just read the words and say a 30-foot ladder leans against a building. So that would be a building. There would be the ladder leaning. It's 30 feet. Okay, and then it says it makes an angle of 60 degrees with the ground. There would be the ground. Okay, so that's all you have to do and put 60. Okay, notice the wording is what leads us to this. It's a ladder leaning against a building. It's 30 feet. The ladder makes an angle of 60 degrees with the ground. So just by reading the words carefully, you'll be able to get this. Okay, now the building is automatically coming straight down. So automatically it makes a right angle, and that gives us a right triangle. The question is asking how high up the building, remember this is the building, how high up the building does the ladder reach? Meaning where does the ladder touch up the building? So all this from here to here, we're calling that X. Okay, now we could use trigonometry, which you just learned in the last lesson. You look at the angle first, and you ask yourself, what do you have in relation to the angle? Well, you have an opposite leg, which is X, and you have a hypotenuse, which is 30. Because in this triangle, the hypotenuse is opposite the right angle, so it's 30. Okay, and which trig function is that? That would be sine, opposite over hypotenuse. So sine of 60 equals opposite X over the hypotenuse 30. Okay, now for this homework and for these problems, you don't need to use a calculator, and here's why. If you go back to the problem, at the end of the problem in parentheses, it says use one of the following. They give you information for sine, cosine, and tangent, and it's always going to be of the angle you're working with. So in this case, we're working with sine of 60. That means you got to use this one, not this one and not this one, but sine of 60. And it's 0.86. So back to the diagram. We put sine of 60 is 0.86. It equals X over 30. Now we do cross product. X times 1 is X. We got to just do 86 times 30. 0.86 times 30. Okay, putting the decimal in. We have 25.8. The 0 at the end is not necessary. So the answer is 25.8. Now they were talking about feet in the problem, so it's feet. Okay, you do not have to round this off. You do not have to do anything like that. You just simply use the number that's given, multiply, and that's it. Same thing when you take a test. You don't have to do any kind of rounding. You just multiply using the number that's given, and you're done. That's your answer, 25.8. Okay, let's go to problem 2. It says a flagpole casts a shadow to a tree 10 feet away on the ground. If the angle of elevation from the tree to the top of the pole is 48 degrees, how tall is the flagpole? Let me explain that. I drew a picture here to show you. When they use the word angle of elevation, you notice elevate means rise up, just like an elevator takes you up. So the elevation angle is always at the bottom and it always rises up. That's why I drew this angle. Okay, now it says a flagpole casts a shadow to a tree 10 feet away. So I drew a little flagpole, cast a 10-foot shadow to the tree, which is 10 feet away on the ground. Okay, so that's 10 feet. And the question is asking how tall or how high is the flagpole. So we call that x. Okay, and you could just do it this way. You could just say the angle of elevation. So you have an angle that opens up, and they're telling you it's 48 degrees. And it says from a flagpole, that could represent the flagpole, to a tree 10 feet away on the ground. Okay, and then of course the question is just asking how tall is the flagpole, so we'll call that x. Again, the flagpole is straight down into the ground, so it makes a right angle. Now when we look at the angle first, we have opposite, x, and we have adjacent, 10. Which trig function? Tangent. So tangent of 48, it's always the trig function and then the angle, equals opposite over adjacent, so that's x over 10. We need tangent of 48, and I'll get that from the table right here, or from what they give you rather. It says 1.12, so we write that down. And then, of course, we just cross multiply. Okay, when you multiply this by 10, a shortcut, by the way, is the decimal moves 1 to the right. So you get 11.2. If you're don't remember that, that's fine. You could just multiply it out. And, of course, they're giving it to you in feet. Okay, so there's your answer. 11.2 feet is the height of the flagpole. All right, now the next problem, right over here, number 3, it says, if a man is just about to ski 900 feet down a steep mountain, or it says, it should say a man is just about to ski 900 feet down a steep mountain. He estimates the angle of depression, I'll explain what that is in a moment, from where he is now to the flag on the bottom of the course to be 24 degrees. How many vertical feet high is he standing? Okay, let's go to the diagram right here. This one is talking about a man on a mountain. Now remember, a mountain is like this. It's not going to be straight down. It goes diagonally across. So he's on the mountain. He's going to ski 900 feet down. So the distance here is 900 feet. I labeled it. And then it says the angle of depression. Now when they say angle of depression, it's the opposite of the angle of elevation. Elevation would be on the bottom opening up. Depression is on the top going down. Now I added this straight line, which is parallel to the ground. So when they say angle of depression, you're going to have a line that you could add in that's parallel to the line on the bottom or to the ground. Okay, and you could use a little geometry, but I'm going to just mention this, and once you remember it, you could do it right away. Remember when parallel lines have a line going through it across, that's called a transversal, by the way. It makes what's called alternate interior angles. It's formed by the letter Z. I'm darkening that in so you'll see that. And the alternate interior angles would be this one and this one. In other words, the angle of depression and the angle of elevation are the same numbers. So if this is 24, this is 24. And that's how you would work with a problem that uses the wording angle of depression or angle of elevation in some problems. So now that we know in the triangle here, we have 24, we have this being x, and opposite the right angle, the hypotenuse, remember they said he went down 900 feet? So the hypotenuse is 900. So now we have an angle, we have an opposite, and we have a hypotenuse. And that, of course, is sine. Okay, so we have sine of 24 degrees, the angle here, equals opposite over hypotenuse. Okay, and now I'm going to get the sine of 24 for you, and just give me a few seconds. It's over here. It's 0.4, okay, equals x over 900, cross multiply, we just got to do 900 times 0.4. If you want, you could just put the one with the zeros on the bottom, because all you have to do to multiply is bring the two zeros down and just multiply by 9. 9 times 4 is 36. You're going to count one back for the decimal, and you'll get 360. Okay, so what does that tell us now? It tells us the vertical distance. Vertical is always up and down, just like a y-axis, and that's 360. Okay, now if they say horizontal, the word horizontal tells you it goes across, just like the x-axis. Okay, those are two important words that you should know. Okay, now let's go to problem number 4. It says an airplane traveled upward at an angle of 49 degrees with the ground. After the plane travels 500 feet horizontally, how many feet high is the plane? Okay, now this one sounds confusing, but if you come over here, I'll show you the diagram and I'll explain it. The airplane is traveling upward at an angle of 49 degrees. Okay, sometimes students go straight up. It doesn't say a rocket is shooting up. It says at an angle of 49 degrees. That means it's going this way. Okay, and that's logically how a plane normally goes, you know, diagonally across. So the plane is going this way, and I labeled it plane so you'll know. It's at an angle of 49 degrees. And then it says now this is the tricky part, after the plane travels 500 feet horizontally. Now what that means is, as the plane is going up in the air, it's passing things on the ground, and that's horizontal, going across. So it's passing 500 feet horizontally. That's the distance from here to here. Okay? And then they want to know how high up with the plane after it passes on the ground 500 feet horizontally. So that's what we're calling x. Okay, and now if you understand it, you could just say here's a plane. Here's the ground making an angle of 49 degrees. And the plane traveled 500 feet horizontally. And after it goes 500 feet horizontally, how high up is it straight up? Okay, and that would be x. So those of you that really understand this, it's okay to just start and do this. If you don't understand it, try to be more elaborate with your diagram and you'll get it right. Okay, now once you have the diagram, again you look at the angle. You ask yourself, what do you have? You have the opposite, x, and you have the adjacent, 500. And that, of course, is tangent. Tangent of 49 equals opposite over 500. Okay, by the way, I just wanted to mention a little more about Sakatoa. I know it was in the first video I gave you. Sakatoa supposedly came from an old Indian name where H's aren't pronounced, so it's pronounced Sa, Ka, Toa. Okay, now if you remember how to spell this, just break it up into every 3 letters. The first 3, the next 3, and it'll give you what you need to remember the trig functions. S is sine, O is opposite, H is hypotenuse, cosine, adjacent, hypotenuse, tangent, opposite over adjacent. So if this helps you, by all means remember that, and you'll be able to get the right trig function. Alright, to finish this, I need to give you tangent 49, which is on the problems that you printed. Tangent of 49 is 1.15. And that equals x over 500. We're going to multiply, cross multiply, and we'll get x equals, so we're going to do 1.15 times 500. Okay, and now as I mentioned before, you could just bring down the 2 zeros if you want, and just multiply only by 5. 5 fives is 25. 5 plus 2 is 7. 5 ones. Okay, and we're done, but the only thing is you got to remember the decimal. 2 places over, 2 places over. So the answer is really 575. You don't need the 2 zeros. So it's 575 feet, which is the height of the plane after it travels 500 feet. Okay? When you do the 4 homework problems, which are also on the lesson, which you could also print to make it easier for you, you should be able to do it. One of them is a little difficult. If you find it really difficult, I'll gladly do another video on that problem. Okay, so please do the homework. Don't forget to email it to me as soon as possible. And enjoy this homework. I'll see you next time. Bye.